Chapter 8, Segment 1. Visual Motion Perception. Motion after effect is the illusion of motion of a stationary object that occurs after prolonged exposure to a moving object. This is caused by the opponent processes for motion detection. Computation of visual motion. Our motion detection cell cannot add up excitatory inputs from A and B. To solve this, we need two additional components in our neural circuit. The first new cell, D, receives input from neuron A and delays transmission of this input for a short period of time. Cell D has fast adaptation rate. Cells B and D are then connected to neuron X. Neuron X will only fire when both cells B and D are active. By delaying receptor A's response, then multiply it by receptor B's response, we can create a mechanism that is sensitive to motion. Said mechanisms would be direction sensitive, meaning they would respond well to motion from left to right, but not from right to left. They would also be tuned to velocity. When bug is moving at just the right speed, the delayed response from receptor A and the direct response from receptor B occur at the same time and therefore reinforce each other. Barlow and Levick figured out that cell X fires only if both its inputs, B and D, are firing simultaneously, and it passes this message onto the motion detection cell M. This is almost certainly not correct. Adelson and Bergen found a solution closer to the truth based on linear filters that delay some and then are followed by non-linearites. Apparent motion. Sigmund Exner was the first to demonstrate apparent motion. He set up a contraption that would generate electrical sparks separated from each other by a very short distance in space and a very short period of time. Observers saw one spark move from one position to the other, even though it was two actual sparks. And the correspondence problem is the problem faced by the motion detection system of knowing which feature in the frame 2 corresponds to a particular feature in frame 1.